Hello everyone. Welcome back to the channel. Welcome back to the channel and welcome to the post-contest discussion of the round Codeforces round 1002, which was rated for the division 2, 3 and 4. So or the participants having less than 2100 rating. Okay, so let's take a look at our first question. I wasn't able to particularly solve the B question as in I I had the logic, but okay, so we'll see. Mm, let's the okay. So there are timestamps in the description. If you want to listen to the solution of the particular problem, you're free. So yes, we are here with the first problem, and yes, an array is called good if for any element x that appears in this array, it holds that x appears at least twice in the array. Okay, so for example, the given arrays are good and the other arrays are not good. Okay, so Milia or whatever that is has two good arrays A and B, so they are both good, and she can arrange the elements in array A in any way she wants. So after that, she obtains an array C by adding the respective elements of both the arrays. So we have to find that if Milia can get array C by rearranging array A in whatever way she wants, such that in C there are at least three distinct elements. So my first intuition for this was, so suppose uh, so our n is starting from 3. Okay, so uh, if n is equal to 3, so there is only one choice, right? So you want to fill this array A or array B, you have only one choice, right? So either it is 1 1 1 or whatever it is, some choice C C C, because it cannot happen that C1 C1 and C2, because this won't be good, right? So and if you go C2, oh sorry, C1 C2 C2, then this won't be good. So that is why all three elements must be same. Okay, in B as well it should be 2 2 2 or 1 1 1, something like that. And if you add these both, you will get 3 3 and 3. Okay, but we didn't get at least three distinct elements, right? So okay, so for n is equal to 3, our answer will always be no, right? So our answer will always be no. Okay, so that's the little observation, I would say. Not really involved much in our logic, but let's suppose uh, in suppose array A, in array A, okay, let me zoom a little bit. Okay, so in array A, suppose you have uh, D1 distinct elements, and in array B you have D2 distinct elements. So if D1 is greater than or equal to 3, or this is logical, or if D2 is greater than or equal to 3, then I can definitely say that answer is yes, because what I can notice here is that, so what I am essentially trying to say is that if D1 is greater than or equal to 3, and or D2 is greater than or equal to 3, then we know that our n must be greater than or equal to 6, right? Our n should be greater than or equal to 6. Okay, so if you try some combinations like a1 a1 a2 a2 and a3 a3, so without loss of generality I am taking d1 is greater than or equal to 3. So why without loss of generality? Because if you can arrange a in whatever way you want, basically you are arranging B in whatever way you want under B, or what you can say, something like that. So that is the thing. And if n is greater than or equal to 6, and suppose this is not holding, if this is not holding, so d2 is not greater than or equal to 3, what about d2 is equal to 1. So these whole elements would be same, right? Then also we'll have a1 comma a2 comma a3 as three distinct elements in our array C, and that's what we want. Okay, so if d2 is equal to 1, our condition will be holding. What about d2 is equal to 2? If d2 is equal to 2, then I know that my array B will be something like b1 b1 and b2 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 and b2. Okay, so again, so d2 is equal to 2. Okay, so this can be the state, or yes, this is the state, or oh, okay. So uh, if we arrange B like this, we will have some a1 plus b1. Okay, so okay, what I'm trying to do here is actually that, so if I try arranging a1 or a2 and a3 in the increasing order, so basically in the sorted order, like here, if we go left to right, our element value of the elements increases. And same for B. Why same for B? Because I can basically rearrange my array in whatever way I want. Okay, so that's the thing. And so if I arrange it like this, then a1 plus b1, a2 plus b2, comma a3 plus b2. So these three will be distinct elements, right? So these three are also distinct. So for d2 is equal to 2 also, we are good. What about d2 is equal to 3? Then also you just do here 3, and then again you are good. So that's why if any one of these two holds, then our answer is yes. So if any of these two isn't holding, then what? Okay, so suppose uh, my d1 my d1 is my d1 can take the value from 1 comma 2, and my d2 can take value from 1 comma 2 as well. So uh, there are four cases: d1 is equal to 1 and d2 is equal to 1. In this case our answer will be no. Okay, so what about d1 is equal to 2 and d2 is equal to 1? So other two cases are like similar case, no, not actually similar, sorry. So ignore what I just said. Okay, so we have to think on that. So d1 is equal to 2 and d2 is equal to 1. So basically uh, array A has two different elements and array B has only one different element. Then can it happen? No, I think, right? So this is also not what we want, right? So this also won't help us. What about now d2 is equal d1 is equal to 1 and d2 is equal to 2 is basically the same case, right? This also won't hold. Now remaining case is d1 is equal to 2 and d2 is equal to 2, right? So in this case, so basically I have a1 a1 a2 a2 and possibly some other elements, and d2 is like 2, so b1. Okay, we have b1 comma b1 comma b2 comma b2. So instead of arranging this in that way, so I will arrange b1 here and b2 here and b2 here and possibly some other elements. I don't care even if they yield the same result as addition from these combinations. So if you add, so you'll get a1 plus b1, you get a1 plus b2. Now notice these two are different now, and again you'll get a2 plus b2. Okay, so you'll get a2 plus b2. So you notice that this element is bigger than this element. Okay, so let me change this thing. So this element is basically bigger than this element because without loss of generality I'm assuming that b1 is smaller and b2 is larger. Okay, so this will hold, this will hold, and I know this is bigger than this. Why? Because b2 is same and our A2 is bigger than our A1 without loss of generality. So this is also holding. So we have three distinct elements, right? So we have three distinct elements here as well. So in this case only our answer is going to be yes. So let us directly head towards the code. It won't take long. Okay, sortings, right, that's right, because inherently we have to arrange this array in because we have to use like the sorting approach here, like here we saw, right? So that is the thing, and that's why sorting. So let's take a look at the submission real quick. There's nothing there actually. I am just taking the input and checking the D1 and D2 with these lines, and this is the basically explained code, explained solution. That's what it is. Nothing much fancier. So let's head towards the problem B. Okay, so in this problem B, so you are given an array A of length n and an even integer k, and you have to split into the k sub arrays and k non-empty subarrays. Okay, non-empty subarrays, and you will concatenate the subarrays which are at the even indices, so second, fourth, sixth and so on up to whatever it is, subarrays to a single array B, and you have to append. Okay, what is it? Append or prepend? Prepend or append. Okay, at the last, add it at the end of the array B. You have to do that, and you have to find the cost of array B, and which is defined as the first index for which the value at that index is not equal to index. So bi is not equal to I, and we have to find the minimum cost of the array B if we partition the array A optimally. Okay, so that's basically the intro for the question. Let's head towards the solution. Okay, so when you take a look at this sample test case, okay, so this sample test case, then you'll basically notice, right? So if k is equal to like n, then our n is going to be even for sure, because k is even. So if k is equal to n, then you have no choice that this is the first subarray, this is the second third subarray, this is the fifth one, this is the seventh one, and this is second subarray, this is fourth subarray, this is sixth subarray, and this is eighth subarray. So if you concatenate the even numbered subarrays, you'll get 1 2 3 4, and don't what you can say, don't forget to add 1 0 to the end. And for this array, our minimum cost is going to be 5, because this is the only this is the first most index, that is like not bi is equal to I, right? So not bi is equal to I. So that is basically the thing. If k is equal to n, then we have only one case in our at our disposal, right? So that is basically something like this, and for that case we can check it independently. What if our n is not equal to k? N is not equal to k. Now n can be even, n can be odd as well. So it is not bounded by the parity of the k right now. So okay, that doesn't actually matter for the solution. So let us take a look at the sample test cases only. So they are quite good, I believe. So big enough, and we are done with this test case, right? Okay, teleport here somehow, and and So we are done with this test case, and here you see now n is not equal to k, and k is definitely less than or equal to n. So my k is less than n. Now I know. So what uh, what I get from this thing is that uh, so take this example: n is equal to 3, k is equal to 2, 1, 1 and 1. So I know that maximum size of an subarray can be, what you can say, n minus k. Okay, what can be the maximum size? So your k minus 1 subarrays will have k minus 1 elements, and means 1 each, and it will leave you with n minus k plus 1 elements maximum in one subarray, right? So this is the number that you can have maximum in these any of the subarray, right? So that's the thing. And what is 3 minus 2 plus 1? So n minus k plus 1 here, it is 2. Okay, so you know that one subarray will have one element and second subarray will have two element. So if you choose this way or if you choose this way, you know that your answer is going to be 2. It won't change, right? So that is basically the point. Not basically that's not the main point. Let's check the here. Let's check in this test case. So 5, 4, 1, 1, 1, 2, 2. So if k is not equal to n, so I know that if k is not equal to n, then what is the suppose if k is equal to n minus 1, so n must be odd, and then n minus k plus 1, which is the maximum elements in subarray which we can have, will be 2, right? So what I can notice here is that, so I will start from the beginning. So I know this element will belong to the first subarray. Okay, if this element will belong to this first subarray, and I so n minus k plus 1. So what is n minus k plus 1 here? It is 2, right? So if I can have 2 elements or 1 elements in my second subarray, right? So here it is 1 and 1. So I know that my answer is actually greater than or equal to 1, right? I can't reduce this down further, right? So if it is like 1 and 1, so I can directly select this. I can directly select this and my answer will be 2, right? My answer is going to be 2. Okay, is there any way that I can get answer is equal to 1? No, because like if like if you go over, so suppose so you want to argue that answer can also be 1 here, but not, because why I'm saying this is that, so consider first two subarrays, then maximum they can have n minus k plus 2 elements. Can you agree? Will you agree? Yes, you will, because other k minus 2 remaining k minus 2 subarrays should have the k minus 2 elements at least, because every one of them is non-empty, because yes, because that's given in the statement. Okay, so the first two subarrays can have at least n minus k plus 2 elements in the total, right? So what is n minus k plus 2 here? It is 3. So basically you notice here that, so you can go till here, right? Just till here. So you have to pick some element in the second subarray from here, right? Second some subarray from here actually, because this one belongs to the first subarray, right? So you want to take something from here. So okay, so will you take only one or will you take all the ones? Because if you take this one as well, so your B will be something like 1 1 and whatever in the front it is. But you notice that B of 2 is not equal to 2. So basically that's the best answer you can get. That's the best answer you can get. Do you agree? Yes, you do. So, and what about if there was a 2 here? What about there was a 2? That's simple. You will take this as a first subarray, this as a first subarray, and you will take this as the second subarray. Okay, now even better, your answer is just 1, right? So what I am noticing here is that so my answer is not exceeding 2 if k is not equal to n. If k is not equal to n, my answer exceed 2. Okay, so solution will go like this. If n is equal to k, then you like hop. So these are the indices, let's suppose 6 7 and 8. So you will hop like this like this like this and check if it is 1 here, 2 here, 3 here or 4 here. So if any one of this misses, so if here it is 2 or if here it is not 2, so if it is 1 or 3 or whatever it is, then your answer will be 2 for that test case. Okay, so for n is equal to k, that's the thing. And if k is not equal to n, then your answer won't exceed 2. And how will you get the answer is 1 or 2? So you have to iterate over the first n minus k plus 2 elements, I assume. So n minus k plus 2 elements, and find if like so so you basically try to iterate over the what you can say n minus k plus so 2 elements based upon our observation n minus k plus 2 elements. First n minus k plus 2 elements, uh, not actually first, you have to ignore this first element and start from the 2. So 2 to these number of elements and check if there isn't 1. If there isn't 1, then your answer is 1, because how we saw here, if it is 2, then remember that I modified the test case. Okay, remember that I modified the test case, I made 2 here. Okay, so that's the thing. If in first n minus k plus 2 elements, if there isn't a 1, first n minus k plus 2 elements starting from 2, if there isn't a 1, then your answer is basically 1. It is better than that, better than 2. And if there are all ones, then your answer will be 2. Okay, then your answer will be 2, and that is basically the solution for this problem. Okay, so actually I kind of missed just this. So I was just checking for k is equal to just I was checking just the second and third element. That was not what had to be done. I checked the first part correctly but failed in the second part. So yeah, I will write it correctly and submit. Okay, so anyways, let's head towards the problem C. So uh, for those who have read the problem carefully, thoroughly, can directly skip towards the solution part of the video. So actually this guy, however you want to pronounce it, works at some shop or manager of the company, whatever it is. So n customers arrive in all queues. More formally, at the jth moment of time, the number of people in the ith queue increases by n positive integer, this thing. So there are n queues, okay, n queues, and this guy chooses exactly one of the n queues to be served at the moment in time. So number of customers in this queue becomes 0 after he serves it, okay. So finally the number of customers in every row are like x1, x2 and so on up to xn, and Nicker or whatever that is, Nikair wants their mix to be maximum. So how will he optimally choose them? Okay, not actually how will he optimally choose them, he wants to optimally choose them. So tell him what is the maximum mix that he can achieve, okay. So my first intuition after reading this problem was for C. Uh, so so when he processes the last line in the sense after the last moment, after the last moment, that line will have 0 customers, right? 0 costs, whatever it is. So I know that my mix is actually greater than or equal to 1 then, because I compulsorily have the row with the 0 customers, because that is the last line I served, okay. So yes, so my mix is going to be greater than or equal to 1. That is my first observation. So uh, let's go step by step ahead. Now what if I want my mix to be 2? What if I want my mix to be 2? So you'll say that suppose q I is the last line, so ql is the last line that I remove, so it will contain 0 elements, so 0 customers, and ql minus 1 be the intermediate last, so the penultimate queue that I processed or served. So number of customers coming to it must be 1. So why am I saying that? Because so can my ql minus 2 be 1? Can it be 1? No, no, because it will be something like 1 comma 1, because it will have two elements. Because it will have two elements, I'm assuming that l minus 2 and l minus 1 are different, distinct, so it will have two elements. It will have one element, okay, and this will have 0 elements. So these two elements can be 1 comma 1 or whatever it is, 2 comma 1 or 2 comma 10, whatever it is, but it will have two elements. So what is the best here? Best in this ql minus 2. So best minimum thing that you can achieve is 2, but I want is to, so my mix to become 2, I want 1, right? So I basically want 1, and that I will get from this row only, and inductively my 2, if I want to make my mix is equal to 3, then my 2 will I will get that 2 from this ql minus 2, I will get 3 from this ql minus 3, so which will be basically 1 comma 1 comma 1, right? So that is basically the thing. And yes, so I think you are trying to notice something. So these are q1, q2, q3, so on up to qn, ql, let's take it ql. So this will have 0 customers, and this ql minus 1 will have 1 customer, and if I want my mix to be 2, it should be 1. Okay, and QL minus 2, what about QL minus 2? If I want my mix to become, okay, that's not a mix, it is something else. So mix to become 3, then I have to have this QL minus 1 as this thing and QL minus 2 as this thing, right? So basically it's a pyramid kind of thing, right? Pyramid starting from the last. Okay, so okay, actually you notice that this is the most important part of the solution, most important part of the solution. So here, if I don't have this row, the row which ends in 3 ones, if I don't have that, am I good to make my mix answer as 4? Because I'm not having 3. Can I convert this row to 3? Yes, I definitely can, because I will take off this part of the row by serving, right? So when like before these 3 men came, or whatever, women customers, let's say, before they come, I will strip off this part, right? So I can convert this 4 into 3, then my mix can become 4. Oh, nice, isn't it? So that's basically the most important part of the solution. And what about that you don't have 3, you don't have 2 as well, but the lines ending with 5 ones, you have 6 of them, so you'll convert this one of them to 2, then you'll decrease it to 5, then again you'll convert one of them to 3 guys, and then 4 here, then 4 here, like something like that. So you'll basically try to fill the gap, right, by the bigger guys. Okay, you'll use the bigger guys to fill the gap of the lower guys. So that is basically what we will do in the solution. And one more tricky part, that's the edge case. Problem was really nicely authored by the author, I would say. So suppose uh, the best possible input, so like n is equal to 3, suppose. So you are like 1 1 1 1 1 1, and suppose 493 here, 493 here, and 493 here. If you'll ask why 493, maybe that's the story for another time, but yes. And this is the best possible input, right? So here you'll notice that, okay, so we have 1, we have 2, we have 3, then our answer should be 4. No, that's not the case. Your answer will be 3. Why? Because the last row, you have to delete the last row, right? You have to have the row with the 0 elements. Then what row will you choose to delete at the last moment? You will choose the first row, right? So you will strip off this whole row when it completes. So let me show you the procedure. So at first second, these entries come. Okay, so now you'll take out this entry. So you take out, oh, that's real thick ink. So okay, you'll take out this guy. Okay, then next at the next moment, these guys will arrive. So now you'll strip off, you'll strip off this part. Okay, so next moment, these 3 guys will come. Now what will you strip off? This guy? No, because you want 1, right? Because you want 1. Otherwise, if you strip off this guy, your mix will be simply 1. If you strip off this guy, then your mix will be basically 2. But if you strip off this guy, your mix is going to be 3, and that is what you want. You want to maximize the mix. So whenever, so there is a upper limit on the mix, right? So there is upper limit on the answer, and that is n. Your mix can be actually n and not n plus 1. It cannot go over that. Okay, so it cannot go 3, and it cannot go 4 for n is equal to 3. So that's basically this solution. I hope you understood it, and let's head towards the code. So this is the input part, and yes, I have simulated the multiset using the set and the map, some cool stuff. Okay, so I don't know that's really cool or not, but yes, here I am maintaining how much final, what you can say, how much streak of the one at the end of every row is there, and how many such rows, right? So how many such rows are there, and then basically I'm simulating the process, right? So you have to use set for this. This code is pretty straightforward to understand, I assume. And yes, so this is also self-explanatory, I assume. So here is the trickiest part, right? So our answer is upper bounded by n. Okay, and if it goes to n plus 1, we have to deduct it. So that is basically the code. I hope you understood all of the solutions. Thank you for watching the post contest discussion. And yes, we are real close to 100 people, 100 community of the 100 on our YouTube channel. So yes, thank you for the support you have shown till, and will show further, and thank you again. And if you learned something new from this video, consider liking it, and sharing it to some needful person, and staying tuned, staying subscribed to the channel. Thank you again.